Hello everyone, my name is Bino. In this video, we are going to determine the general solution of the following linear first order differential equation. And when we determine the general solution, we have to make sure that the dy over dx is not attached to any variable or constant. So we are going to divide through the equation by that x so that we only have that dy divided by the dx. And on the right hand side of the equation, all the functions have to be functions of x. So the y will be on the left hand side with the dy divided by the dx. But first, if this equation is arranged in standard form, we have to extract what we call the integration factor, which is equal to e raised to the power the integral of that p of x dx. We'll multiply this integration factor with that equation. So we have the dy divided by the dx, which we multiply with the integration factor, the e raised to the power the integral of p of x dx, plus the p of x multiplied by the y. We multiply it also with the integration factor, the e raised to the power the integral of p of x dx. And what we do on the left, we also do on the right. So even that q of x, we multiply it with the integration factor. And from here, we will be concerned with the y multiplied by the integration factor. So the y multiplied by the e raised to the power the integral of the p of x dx, and we are going to differentiate this. And in order for us to differentiate this, we have to use the product rule, since we have the product of the y and the e raised to the power the integral of p of x dx. So the derivative of this with respect to x, using the product rule, we first differentiate the y and we multiply it with the e raised to the power the integral of p of x dx, plus derivative of the e raised to the power the integral of p of x dx, and then the derivative of that will be equal to the e raised to the power the integral of the p of x dx. And according to the chain rule, we also have to differentiate the inner function, the integral of the p of x dx. So the derivative of the inner function, the integral of the p of x dx, and we have to multiply this by that y, and this will be equal to the dy divided by the dx multiplied by e raised to the power the integral of p of x dx, plus the e raised to the power the integral of the p of x dx, and the derivative of the integral of the p of x with respect to x will just be equal to the p of x. So the derivative of the integral of a function will be equal to that function, and remember we have that y, and this looks familiar. So let's see, we have this equation. So the derivative of this y multiplied by e raised to the power the integral of the p of x dx gave us exactly this. So we differentiated this and it gave us that. So let's take a closer look. We have the dy divided by the dx here, and even here we have the dy divided by the dx. We have this e raised to the power the integral of p of x dx, and we still have it there. We have this p of x here, and the p of x is there, and here we have this y, even there we have that y, and we also have the e raised to the power the integral of the p of x dx, and even here we have it. So the derivative of this part gives us this whole. I hope this makes sense. So from here we can conclude that the derivative of the y multiplied by e raised to the power the integral of the p of x dx, y multiplied by the integration factor, when we differentiate it, it will give us the left hand side. And we also have the right hand side as the q of x multiplied by the integration factor, the e raised to the power the integral of the p of x dx. From here we can integrate both sides of the equation with respect to x, and the integral of the derivative of a function will be equal to that function. So this will be equal to the y multiplied by the integration factor, the e raised to the power the integral of the p of x dx, and on the right hand side we still have the integral of the q of x multiplied by e raised to the power the integral of p of x dx, and we have that dx. So we can conclude that this will be equal to y multiplied by the integration factor, which will be equal to the integral of the q of x multiplied by the integration factor dx. So for our first question, we have to evaluate this general solution. So we have to divide both sides of this equation. We have the x multiplied by the dy divided by the dx plus y, which is equal to 1 minus sin x. We divide through this equation by x so that we make sure that we only have the dy divided by the dx alone and not attached to any variable or constant. So the x divided by that x will be equal to 1, so they will cancel out, such that we'll have the dy divided by the dx plus 1 over x multiplied by y, which will be equal to 1 minus sin x divided by x. Now we determine our integration factor, which is equal to the e raised to the power the integral of the p of x dx, and our p of x is equal to the 1 over x, the 1 next to the y, and the integral of the 1 over x with respect to x will be equal to the ln x, and e raised to the power ln x will be equal to x. So our integration factor is equals to x. Remember what we said? We derived this formula where we had the y multiplied by the integration factor, which was equals to the integral of the q of x multiplied by the integration factor dx. So we have the y, and our integration factor, we determine it as x, and this will be equals to the integral of the q of x. We determine that our q of x is equals to 1 minus sin x divided by x. Our q of x, 1 minus sin x divided by x, and we multiply this by the integration factor, which we determine as x, and y multiplied by x will be equals to the integral of, so we have that x divided by x, which will be equals to 1, so they will cancel out, and we'll have the integral of 1 minus sin x dx. So y multiplied by x will be equals to the integral of the 1 with respect to x, which will be equals to x minus the integral of the sin x, which is equals to negative cos x plus the constant c. So y multiplied by x will be equals to x plus the cos x plus our constant c, and this will be our general equation. So you can choose to divide both sides of this equation by that x, but I'm just gonna leave it here. Thank you guys for watching up until this point. If you have any questions, do leave them in the comment section below. Remember to subscribe, like and share the channel if you find it useful.